Well, after this long time spent on definitions and theory, I usually say that these settings or this knowledge is more important actually than programming itself. Because programming, you have a little difference here and there on how to do things from one robot to another manufacturer, but those concepts and those theories are fundamental to create a base that serves to every other robot, regardless of the robot you're working to. So Fanuc, ABB, Cook, Model Man, these concepts and settings suits everyone. So it's important to keep the theory very clear in your head on how to do things because by doing it, you can get a clean code that is understandable to others without special tricks that could harm others or affect the process and the productivity of the line or the safety of the line. Okay, now we're going to see, I will show you in this class we're going to use our training modules for that we created in other classes. And using it, let's see some things. Um, so basically, when we create a module, we have some options, okay? One of them is that when I created our training module here, for example, which is named Treinamento, I will have these two options here, select and open. And what's the difference between them? The difference is, for example, if I click open, I will then be able to visualize everything inside of this module, inside this routine. I can create commands, I can edit the logic as I want to here, no restrictions at all. But my program pointer is not in this routine. So if, for example, I want to execute instructions here, like moving the robot, this will not be possible because my pointer is not here. It is not located inside this program. We will see this with a bit more detail later, but basically when I click here, I'm not able to run or cancel or reset the program because running is not enabled either because the pointer is not inside any program. Let me close this view now. And now when I click select instead of open, look at this. Look at this. When I select, my pointer already appears here inside the program. And now, if I look up here, I have different status. So here I can actually cancel or reset the program if I want to. And if I cancel, it goes back here to the navigator screen. And here I can select or reopen a different routine. Okay, and of course here we cannot execute the program because the button is grayed out because no routine was selected for the pointer to go to. So that's it. When I click on select instead of open, I'm moving the program pointer to this routine. Back to open option for us to edit the program, create movements, create logics, everything. And now we will see how can we create movements and conditions here. And before going into this on creating movement and stuff, I would like to show in practice uh, some parameters that I mentioned earlier. And those are the attributes of the movements we saw in past classes, like zone fine or continuous movement or precise. Oh no, my machine is freezing again. This virtual machine is running with only 2 gigabytes of RAM, so sometimes it freezes a little. Okay, I think I'm good now. Okay, now I'm good. So basically, for us to create comments, movements, and everything, we can click on comments here, go to movements, and we will use PTP or punch point, okay? And here now we have some arguments in the structure of this instruction. So we have this line of code here with a lot of parameters, and the first one represents the movement type. It can be a PTP, linear, or circular. And clicking here, we can see all the types that we have here. This second argument here is the point, also known as robot target, a point for the robot to go to, basically. And it is a variable that stores the position and coordinates and everything regarding the point that the robot will move to. This third argument relates on how close the robot needs to get to the target point, to get to the point specifically that we can set up in KUKA or to get a bit close to the point, but not passing exactly in the point. And the fourth item, actually, we have the speed. When we work on a PTP, we have percentage. And the fifth item represents the parameters related to the approximation data. So approximation distance, acceleration. So if we selected count here beforehand, the parameters to configure it would be here in the fifth element. And also some things like reorientation control on trajectory movements and things like that. But let's see if you want a robot to go to a specific point. So if you want a robot to the robot to get exactly to the point you set, then you need to leave this argument here empty, just like that. So this means like zone fine on ABB. It means that the robot would go pass exactly through the point during the movement. It would not do approximation movements, or it would not pass close but not inside. Okay, if I click on command OK here to confirm my instruction, here is our movement. So a PTP movement. It is configured to count mode with speed set up to 100%. And the data here are regarding the tool and the base that I'm using to do these movement instructions. Oh, so something I didn't show to you actually is that when we use count here, it's same as the zone. And for us to change the parameters here, we click on this button here. So when we have count selected, we can click here. And we will have acceleration in percentage and the approach distance you want to use. So you get it by reducing here. And remember, it is not because you're using count that you have one fixed value for every movement that a robot will do. We can parameterize movements with different approach distances and acceleration, depending on every case and distance needed for each point. So when you're all set up here, define your acceleration and your distance. Okay, now the count mode will be executed using these references, a set point for acceleration and distance, and when you click commands OK here, this movement will be added, in this case to point 2, using approach distance as configured and 100% speed. So this is the option to save and insert instruction.